Hi, and welcome to the third video in this series. In this video, we'll be covering operation setup with some minor optimization work. So, continuing to use the model that we've constructed over the course of the previous videos, we first want to orient the model for the best access to the finished surface. In doing so, we must be mindful of the orientations available to us from the turntable. As such, I'm going to reorient the second turntable axis by 90 degrees, so the long edge of the workpiece is presented towards the robot. To do so, we go to axis E2 in the Setup tab, and where it says 0, we replace that with 90. Now, we want to assign an operation to actually start the toolpath process. In the Operations menu, situated on the top right corner of the left-hand tab, we're going to select a Morph operation, which is under the 3D and 5D Advanced submenu. We're going to choose a spherical or ball nose mill for this. Let's go for a 30mm one, just so we're able to see the toolpath clearly. We're also going to change the length of this mill a bit as well. We'll bump it up to 150mm, just to be certain that we're not going to get any collisions. Now, we're going to move on to the Job Assignment tab, just under the Setup tab on the left, and define the job zone that we want the robot to work on. Firstly, we make sure that the face selection is turned on, along with edge selection. Then we click on Machining Surfaces on the left-hand side of the screen and select the top surface of our part. Once that's done, we want to choose the first curve, in this case the curved edge that's nearest to us, and do the same for the second curve. This is a requirement that's specific to the Morph toolpath, since it's designed around giving the cleanest transition surface between the two defined curves. Now that we've defined that, we can click Run to calculate the path. However, we can see that nothing much has happened. Obviously, this isn't the result we want. The reason for this is that the orientation for the robot relative to the rotary table, it needs to be able to articulate cleanly across the curve, and the current position of the robot precludes that, as does the fact that the turntable is also not set to move. The easiest fix for this, and a very handy feature of ENCY's workflow, is to adjust the 6th axis control. If we click on this, we can adjust the point relative to the robot that the 6th axis is articulated around. We can see that when the option is selected, an indicator of the robot's articulation range is shown. What we want to do is change this around so that the arm has a freer range of motion. To achieve this, we're going to grab the widget that's in the robot's elbow joint and bring it around so it's offset from the robot arm itself. This adjusts the orientation of the tool axis around its relative Z, so you can see the wrist joint starting to articulate based on this. This means that the wrist joint can now move around the curved surface in front of it. Now we can recalculate the toolpath by clicking on Run. You can see we've already got a result. We're not done with this, however. Let's adjust the tool step over to 60% from its original 20%, so we have a shorter overall toolpath and get a clearer picture of what's going on. This can be done in the Strategy tab. We're also going to change the tool axis orientation, changing it from fixed to normal to surface. We might as well make full use of having a robot's range of motion after all. With this particular setting, we will get a better surface finish when using a Morph operation, since tool perpendicularity will minimize chatter and makes fullest use of the tip geometry. For every change we make like this, we will have to rerun the toolpath calculation. Fortunately, due to ENCY's innate optimizations, it's a quick and painless process. For the sake of keeping the display free of artifacts from previous calculations as well, it's usually worth clicking on Reset to clear all previously shown toolpath actions. So, we now have a valid and viable toolpath. Let's simulate it now to see what happens and how the program works. Click on the Simulation tab in the upper left of the screen, and click on the play icon to start the simulation. The slider that's directly beneath the play and stop buttons controls the speed of the simulation, so you can either choose to fast forward your way through bits you're confident about, or you can slow right down to double check the toolpath viability. However, now that we're watching the simulation play out, we can see that the turntable isn't moving at all, and the robot has to reach a long way to be able to achieve the perpendicularity from the finished surface that we wanted. While the toolpath nominally works just fine, it's far from perfect. So let's look at making the turntable move in sync with the robot. Going back to the Machining tab and the 6th axis control subsection, we can see that there's a control called Rotary Table Vector. This is typically set to auto, which clearly isn't doing as much good at the moment. So we have the option to define the position of the turntable relative to the tool axis, as indicated in the control below. We're going to set the turntable vector to positive Z, and then we're going to enable the Rotate E1 function that's just above this setting. This will mean that the first axis of the turntable will be able to move, and should keep with the preferred orientation that we've just defined. So now we're going to click on Reset, then Run to see the outcome of these changes. If we move over to the simulation environment again, click on the Reset Workpiece button, then press play, we should see the turntable and the arm moving in sync with each other to machine the workpiece in a manner that relieves all of the reach issues. This concludes this video. In the next video, we'll be covering the use of the axis map, or to give it its full name, the Redundant Axes Mapping Tool. This remarkably powerful tool gives us the ability to optimize and improve toolpaths around almost any stumbling block in a program.